Hi guys, I'm Tony Aldon, and today we're going to write a little Emacs Lisp programs that do string replacement on the characters highlighted in this current buffer. So we're going to see how to use the function search forward regresp and replace match. Also, we take this opportunity in the first part of the video to introduce the tool Rebuilder that is here. We have it in the comment where we can see in its help buffer that help to construct a regresp interactively, specifically with visual feedback. So first, Rebuilder. Here at the top you can see that I've put some of the main key bindings of the main commands that we are going to use today. And if you want to rebind them or see other commands bind on in Rebuilder, you can look at reb mod map. So let's get started. And in this video, I bound Rebuilder to Control F1. So here at the bottom, we have a buffer in a small window where we can write regular expressions that are going to be matched and highlighted in the buffer notes.l where we called Rebuilder. So let's match foo. Cool. We have visual feedback. Maybe we want some space and we want to match bar. We also match bar. This is great. We have that. Let's say we want to quit Rebuilder because we don't need that regular expression in our program. We change our mind. We just have to press Ctrl+C, Ctrl+Q. We quit. Everything all right, and we can continue with our work. But we want to go further with Rebuilder, so we call it again. And now, here, when we are writing the regular expression in the Rebuilder buffer, we have a type of regular expression. So let's call Ctrl+C, Ctrl+I that can change the type. So we can see in the mini buffer that right now we are using the read syntax that use double backslash for some characters, and we could also use the string that use only one backslash character, and this is what the regular expressions are used when we write a regular expression with the function, the interactive function query replace regresp. So I quit, and we are going to see what does that mean specifically. So let's say we want foo or bar. If I write just backslash and the pipe and bar, it doesn't work because right now we are writing with the type read, read for the read function of Emacs. So we have to add a double backslash to be able to have the sign or, and we have it. So now we are matching on each line either foo or bar. So this is great. But no, this is great. Fine. Now let's say that we want to copy this regular expression to use it in our program. We can do Ctrl+C, Ctrl+W, which is reb copy. So let's do that. We have it, and we can see at the bottom in the echo area that tells us that this has been copied and put in the kill ring. So now if we go in that buffer, we can paste it. Okay, so, and this is the regular expression we are matching, and we can use it in our Emacs Lisp programs. We removed it. We go back in the Rebuilder here, and now let's say that we want to write the regular expression with only one here one backslash. So we can do that with Ctrl+C, Ctrl+I that we did before that call repchange syntax. And now we're going to choose the string syntax. Remember, the string syntax is the syntax that we use when we use the function query replace regular expression, regresp. We change it, and now we can see that it changed to one backslash. Maybe you don't trust me, and I encourage you to not trust anybody, or at least don't trust me and verify what I do on your own Emacs. And now we are going to match foo or backslash only one, maybe baz. So here we match only foo or baz, or maybe we can change it with bar or baz. So here we use it like that. Now, if we copy the same way we did before with Ctrl+C, Ctrl+W rep copy, this won't copy what we see on the rebuilder buffer, but this will copy with the type of regular expression used by read. Why? Because this tool rebuilder is really a tool built toward writing programs and not to use the regular expression interactively. So we can see that it really copy in the echo area. It copied like before with double backslash, and if we copy it there, we see that we have double backslash, which is the syntax recognized by the function read. So, okay, fine. What can we do is something else that we can talk about a rebuilder before we switch to our little Emacsys program. Yes, there's one thing that we can talk right now. We are going to still continue to write with the string syntax, the string type, because it's more convenient. And one thing that here we can see is like when we match foo, we also match, so we are going to jump here in that line. Don't know if you see, we also match the foo with F uppercase. So this is due to the variable case for search that we can see at the top in the comments. That let's look first. We quit a rebuilder to not mess up the help buffer, and we see that its value is true right now. And what does that mean? We read it. No nil if searches and matches should ignore case. So when it's true, we ignore the case that we passed in our searches or matches. That means that if in the search that we do, we pass only down case characters, this will match also the upcase characters. So this is what we have. We can change it here. So up, we have this one. Let's see this. We can evaluate the last expression, and you see it's true. If we search for, let's see that we search for foo, it's match everything as we mentioned. And now, if we change it to nil, we evaluate. Case for this is nil. So if I pass foo, we respect the case. So we search again for foo, and now we can see that we are no longer matching the two words foo with upcase. Okay, so this is something that sometimes when we don't know what's happening with our searches or matches, either interactively on our program, two things can happen. How maybe case for search isn't set the way we think, or This is a case that we are not going to see today, but I mentioned it. Or maybe we've modified the match data that we match with a search before working on it. So here it is. We put it again to true as it was before. We remove because we no longer we're going to use it a little bit after. I want to show you something before, so we keep just the variable to be able to evaluate that variable after. And let's go back to Rebuilder. Why I show you this with the variable? Because there are a command in a Rebuilder that is mapped to Control-C, bound to Control-C, Control-C, which is rep toggle case. And rep toggle case, it just changes the value of case for search, and so it changes if it will match as we've seen right now with the up case or down case. So now case for search is true, we ignore the cases and we are matching every foo. Now let's call Control-C, Control-C, rep toggle, and we can see that we no longer match foo with the F up case. We can change it again. Okay, so we see that the thing changed like this. So let's say that we are going to match everything, and we change it after. Let's just let me 1 second to see if I told you everything I wanted with Rebuilder. So yes, so here is the introduction to Rebuilder. With that, you and I can use it when we are writing programs. It's really convenient, fast, and beautiful. So yes, now we quit it, and maybe we are going to use it after when writing our programs. So now we want to the goal. First, I tell you the goal. We are going to change in those two lines the dash dash and plus plus with 4 double underscore and the exclamation characters with 2 interrogation characters. Okay, so we are going to write a program that do that, and so are going to use a regular expression to match exactly what we want. And you can see there we have XX, so this maybe won't work. Maybe this one could have worked, but we don't want to use to match if foo is upcase. So we want really something that start with foo, have something double dash, and end with exclamation, and start, or this one start with foo, double plus, and end with an exclamation. So this is the goal, but we are going to write the program step by step. It's not quite step by step, but just to have a sense of how works all those functions that we are using, and we introduce some things from Emacs. So the first thing is to use that function. Maybe we can read the help buffer of that function. Here we have the synopsis. So that function takes one mandatory argument which is regresp, so the regular expression we want to match, and then we have true that are bound no error or count, and we are going to use no error at some point. And what does it do is search forward from point, so where we are, for regular expression regresp, and it moves the point. You can read this here. Set point to the end of the occurrence font and return the point. And here this variable, this function sets the match data and so we can use after that those functions that use the match data. And specifically the one that we are going to use is replace match to replace some sub-expression of the regular expression we search for. So let's start with foo. And now if we evaluate that expression, so we evaluate, it move and it matches the first foo we have in the buffer. Perfect. This is what maybe we wanted to do. Now, what we want at the end, no, not at the end of the day, but at the end, what we are going to do is to loop on every match and do the matches, the replacement with the match data of the match we search for. Now, we are going to do something. This, as I said, we do stuff, and at the end we are going to have the final result. Each time we match, we see that we move the point, and we are going to insert 4 x's. Before I evaluate that, this won't work. Okay, I want to show you this because it won't work, and we are going to see how to make work in the sense that this will return an error. And we are going to see why. Error. Why do we have an error? If we search, we move, and we do something. So here we can read search failed for foo, and we did what we wanted to do, and at some point we do a search here and it doesn't work. Let's quit that buffer, go back here. If we look here, each time we match foo, we've added 4 x's, but we have an error. So for the people that already know, maybe it's boring what we are doing, but for the other that have never used a search for a regular expression, bear with me because we are going to see why this happened. So the thing is that when we are at the last one, the last match here, and we continue to match, this function that try to match another foo at the end return an error by default. Okay, so there are 4 arguments that we have seen before, and the last one is no error, and no error is that if we set it to true, it won't return an error if we don't match. Sometimes we really want an error. Let's say that you are looking for a regular expression, and if they are not in the buffer, really this is an error because we can't go further with that buffer, so we want an error to see that there is a problem, but sometimes it isn't. We just want to match till the end where they are not. So we undo that, we take it, and what does that mean? Just that if we put it there, we evaluate, and we are going to have an error because at the bottom of the buffer, we are at the bottom, okay? So there's no other foo. We evaluate an error. This comes from the error. So the thing that we can do, bound, we don't bound the search. You can look at the echo area. We are at the second argument bound. We search in all the buffer, no limit, and now we put it true. This will return nil because there are no foo after in the buffer. So this is what we are going to use now. So we go back here, we do that, we evaluate again. Okay, so now it's not super cool, but it's not so bad. We are closely, how to say, reaching the end program. But you've seen something that did happen, that the cursor moved. Maybe we don't want the cursors to move, and that way we are going to be able to just evaluate where we are in modifying that expression, and we leave the cursor unchanged. So this can be done with the function that is save excursion. Okay, so now if we do that, we evaluate this expression, and everything here that is in that save excursion macro is code that is evaluated without moving the point after. So you see, the cursor hasn't moved, and we can do it again, and it doesn't move. Okay, so undo, undo, undo. We have that. Okay, this is not so bad, but let's see some things that before we talked about case for search. Okay, so do we ignore the case, or are we going to not ignore the case? Right now, we evaluate again. We see that we ignore the case. We search for foo, and we can see here. Okay, so we also inserted 4 x's for the match of foo with f uppercase. Normal, because right now, if we look at that variable that we're going to, I just evaluated it. Look at the echo area. We have a true. So now true is we ignore case. But in what we want to do, we want there not to. We want only to match those lines that start with a foo that is not uppercase. So we wait a second. I will just up. Okay, so we are here, and we are going to use that one. So the thing is to, on the search, we wrap it with this value being nil. Okay, so right now, when we are here, the value of case forces is nil, so we are not going to match the one with the f uppercase. So let's see that. Okay, fine. You see, nothing, no x's have been added on those lines. Okay, so we are really close to the end program now. We said that we want to do something that is a replacement and not just inserting. So let's say the function for that is replace match. We can read that. It takes at least one argument that is a new text that will replace the match data that has been set in the previous search or matches. Okay, so we do the search, the match data is set to something, and with replace match data we can operate on the information we have in the match data. So here we are going to use this one, and we don't care about fixed case, literal neither, and string neither, but at some point we are going to use the sub expression where we put the number of the regular expression to replace just the sub expressions that we match in our regular expression, which is not the case so far, because we just matched foo without any sub expression. So let's replace foo by 4 x's. And we no longer want insert. We are here. We evaluate. Okay, so this happened. So we can see here the foo disappeared, and we replaced them with x. So it's not so bad. This is part of what we wanted to do. But now the thing is that we want a regular expression a little bit more advanced, or more with more complex, that will match what we said before. We want to match that start with foo down case, then double dash or double plus, and that end with this one. Let's say that we don't know how to do that directly, and we want some feedbacks, visual feedbacks. Okay, this is why we introduce Rebuilder at the beginning. So let's call Rebuilder. We're still at foo. We see that right now this is also matching the foo upcase. So Ctrl C, we change it, we toggle the case to really not ignore the case. So foo is great. Now we want to match dash. It doesn't work. We have a space. This is not a space, so maybe any character. We match a dash, but we see it is not matching the first dash. It's normal because here we put any character. So what we can do, maybe we want a dash and we want twice. So sorry, because we don't see it as a sub expression, so it's not as clear as we want. But anyway, what we want is really a sub expression of a dash. So here in color Azul, more dark, we have the dash, but we have only the second. If we put 2, it will match this one. And we want either this. The regular expression we are writing is not the best one that we can do, but we are not here to write the best regular expression. It's just that it's to showcase the interaction we can have on the programmer experience we can have with regular expression on Rebuilder when we are writing a program that do string replacement on a buffer. So here we are matching either minus or plus. Maybe we can add, as I tried to do before, we want to match 2 of them, so we can do this with braces. So now we match 2 of them. They are inside parentheses, so this is the first sub-expression that we are going to replace after. Maybe now we match everything else. We want to match exclamation but as a sub-expression, so we use the parentheses, and now we are matching exactly what we want. Okay, so maybe there are better regular expression. Let me know in the comment if you have one. It's not a general case, it's just what we do. So let's copy it. We copy it. This is in the kill ring. We no longer need it, so we quit Rebuilder. We go there to foo. We remove this one. We add the regular expression that we want. Now we can see here that it did it the way we wanted and the way the Emacs program runs, with double dash for escaping. And now let's evaluate that. Say, okay, right. Not bad, because we really match what we want to match, but the replacement we are doing right now is that we replace the wall match. So these things match the wall line. So this is not what we want to do, and we are going to use what we've seen before, which is we want for underscore, and now you can see in the echo area we have 4 optional arguments, and the last one, the fourth, is sub-expression. So we want to replace the first sub-expression. So we write nil for the third one, and here we write 1. Okay, sorry. First, I should have done. I will undo that what I've done here just to put again those lines. Okay. So now, this is what we want to do. We have this one. We removed. Up, not so bad. You see here that we replace the first sub-expression, and now we can do something else, which is to interrogation in the second expression, and as I did, I forgot to do it like that. Okay, so this is what we want, and now let's do it, and it should work, and it works. So this is a little program I was talking to you at the beginning of this video. This is how you can get started if it's the first time to write your program to do string replacement. You can use Rebuilder to help you when maybe at the beginning, if you're really beginning with a regular expression, or if you're more advanced for more complicated regular expression. And this is all we have for today. I hope you enjoy the video, and you get value from it. See you next time, guys.